Good afternoon, everyone. Thank you very much for joining us in this fourth installment of the Philippine Geographical Society's Lecture Series for this year. So for today, we are very fortunate to get to know about how geospatial data is visualized in various interactive maps and other applications, which surely would pique the interest of our audience this afternoon. I am PJ Cipriano, one of the board members of PGS, and I will again be the moderator for today's session. Before we officially begin our program, let me go over some house rules governing our lecture series. Please be reminded to keep your mics on mute mode during the discussion to avoid unnecessary background noise. Also, please note that this lecture is being recorded for documentation purposes. We would like to encourage everyone to actively participate in our discussion by typing in your questions, comments, or reactions in the Zoom chat box. All of these will be addressed during our open forum later. And before we end our meeting, we would like to request our participants to turn on their respective cameras, if possible, for our group photo. Thank you very much. Now for our opening remarks, please welcome the President of the Philippine Geographical Society, Professor Eman Garcia.
Isang magandang hapon po sa ating lahat. It is my pleasure to welcome everyone to this afternoon's PGS Lecture Series. The PGS LS is a monthly knowledge sharing talk and conversation among geography practitioners, alumni, and allies in the field, showcasing research and practice focused on the Philippines. This is the fourth lecture that we are having this year and the 19th overall since we started the PGS LS last year. I would also like to acknowledge the UP Department of Geography for co-sponsoring the event. This is a very special session of the PGS LS, not only because of the timely topic, but because our guest speaker is technically not a guest. In fact, she is one of the reasons for the continued success of the PGS LS, as she has always been the designated moderator for most of our lectures that we've had in the past. I am personally very interested in the topic that we are having this afternoon. And if you have seen the publicity material for this lecture, there is a provocation in the description that I want to echo, and I quote, "Digital maps are entrenched in the social fabric of this generation's milieu in ways too various to specify. How do we make visible geospatial data in ways that are accessible, informative, democratic, and compelling?" Diba? Napaka-exciting to see how this could or would be possible. As is the tradition that we have made for the PGSLS, we made a word cloud of your registration keywords. And for this session, dominant words are engaging, innovative, interesting, dynamic, useful. I personally like other entries including awesome, fun, amazing, colorful, and most especially powerful. These are wide-ranging entries which I think makes our session this afternoon all the more interesting. On this note, I would like to thank everyone for joining us on behalf of the Philippine Geographical Society and the UP Department of Geography. Welcome, and as always, I hope we have a special and productive afternoon. Thank you.
All right. Thank you very much, Sir Eman. I am sure that everybody is looking forward to the talk this afternoon. So let's now introduce our speaker. Our speaker is a geographer and geographic information system professional with years of experience in project implementation, database design, cartography, and training and technical consulting services. She has a bachelor's degree in geography from the University of the Philippines and has also previously served as a lecturer in the Department of Geography. She is the Deputy Director of Professional Services in Geodata Systems Technologies Incorporated. In her line of work, she has implemented enterprise GIS in numerous organizations and deployed geospatial solutions that support and improve the customer's business workflows. To give us an idea more on how we can visualize geospatial data in interactive maps and apps, the Philippine Geographical Society is honored to have Ms. Kathy Ilustre, who is part of our Board of Regents and the current Vice President for External Affairs. Please give her a virtual round of applause by clicking the clapping emoji here in Zoom.
Hi, good afternoon. I'm Kathy Ilustre, and as part of the introduction, I am actually affiliated with two organizations, Geodata Systems, the Philippine distributor of ArcGIS products, and I'm also an active member of the Philippine Geographical Society. So today is Earth Day, and it is a perfect day to discuss about geospatial data and maps in the session of the PGS LS. We have long used maps to visualize the Earth's surface, events, and objects that are located in this world. For this session of the PGSLS, we will shift gears a little bit. So, if you have been attending previous sessions where presenters share the results of their research work, well, in this session, it will be a technical presentation focusing on how we can use interactive maps and apps for visualizing spatial data. And if you have previously used maps to search for the fastest way to get from one point to another, check the location and forecast of a typhoon, check for nearby facilities such as restaurants, school, other facilities, well, for this session, we'll take a peek at the other side. This will be on the perspective of the map author, the one who prepares the maps that will be used by the users. For the format of the presentation, I'll first discuss concepts on some of the features of interactive maps and apps, and basic design and principles and components of interactive maps. For the discussion, we'll touch on cartographic concepts, but it will not be an extensive discussion. It will be more like a teaser, an introduction. We'll then move into exploring these concepts in various geographic information system or GIS applications. GIS is actually a software that integrates location data with descriptive information. Specifically for this presentation, I will be making use of ArcGIS applications as we explore various ways that we can visualize geospatial data. For the data sets that we will be using in the application showcase, these are either produced by my colleagues from Geodata Systems or are readily available in the online portal. So, interactive maps and other terms that commonly refer to the same thing include dynamic maps and web maps. All refer to a map that is, well, not static, meaning that the user can interact with a map by changing the location, change the scale of the map by zooming in or out, view a description or information about the objects on the map through pop ups or panels, or even update the map. For this presentation, I'll mostly use the term interactive maps since it provides a notion that there is a user who is interacting with a map through the use of a computer or a mobile device. The apps part refer to web applications that integrate maps in the interface and enable the user to interact with the dynamic maps. Here are a few of the features or functions that we can expect when working with interactive maps and apps. So, an interactive map or app can compile data from various sources. Data can be in the form of points, lines, or polygons, which are typically used for representing real world objects and events on the map. In addition, data in a spreadsheet or from sensors can be included. Scanned documents and photos can be attached to the geospatial data, and satellite imagery can also be incorporated. Data from the field or crowdsourced data can likewise be gathered using interactive maps and apps. An interactive map can also access information about the objects on the map and display it in pop ups, tables, or charts. For example, an interactive map that contains a barangay layer. The user can click on a specific barangay polygon to see its characteristics or attributes, such as name, size, and population information. Or the user can open a table showing the characteristics or attributes for all the barangays. An interactive map or app displays symbols that get updated when information changes. The creator of the map can choose to show just the location of the object or event, or include an attribute to symbolize the point, line, or polygon on the map. When an attribute value used to symbolize the data on the map is changed, the symbol also changes to reflect the updated attribute value. For instance, with a land use map, when the attribute value of a polygon is changed from residential to built up area, so the symbol on the map also changes from a yellow color to a red one. Interactive web apps enables users to perform spatial analysis. Common spatial analysis operations include finding out what's nearby, how is something distributed, how are things related, or how has something changed over time. All right, so let's look at these features of interactive maps and look at how we can design them. So in some aspects, designing an interactive map is different than designing a map for print. I would not elaborate on these differences, but rather I will highlight some of the basic things to consider when designing interactive maps. So an interactive map can be zoomed in and panned by the user. As such, the map author needs to plan for the map to be displayed at different scales. Map scale refers to the relationship or ratio between distance on the map and the corresponding distance on the ground. So a 1 is to 100 map scale means that 1 centimeter on the map is equivalent to 100 centimeters on the ground. Planning for a scale-dependent display means that the map author needs to choose the appropriate scale range for when symbols, layers, and text should appear so that the web map is made to be easily comprehensible by the users. Since interactive maps will be displayed on devices that emit their own light, lighter symbols on dark background can be used. Choose colors that would have good contrast with the background. Of course, if you are incorporating the map in an app, choose a color scheme that will go well with the other elements of the app. Interactive maps can be viewed on laptops, smartphones, tablets, widescreen monitors, or even be projected on a wall. The size of the device will influence the design of the interactive map. The recommendation for this is to start designing the map for a mobile device user experience and then design it for screens with larger screen sizes. For example, on a desktop monitor, a pop-up can easily be displayed, but due to limitations on the size of the screen of a mobile device, additional information may need to be shown on a separate page instead. And just like any other information product, the map author should design the interactive map by considering who will use the map and what is their purpose in using the map. Is it a decision maker viewing the interactive map on a mobile device, or a field worker collecting new data using a tablet, or an office personnel viewing the data in a large screen at the command center monitoring field personnel and events? Identifying the needs of the audience and the purpose of the interactive map will help the map author in designing the look and feel of the map and what the user experience will be. Now that we have discussed the considerations for designing interactive maps, let's move to some of the common ways of symbolizing geospatial data. So when we say geospatial data, it has a location component to the data, in addition to the descriptive characteristics, which are usually stored in rows and columns in a table. On a map, an example of geospatial data would be major cities. At a certain scale, points are used to represent real-world cities such as City of Manila, Cebu, and Davao. If we just wanted to show the location of the cities on the map, we can use a circle of the same size and color to represent all three cities. But then location is just one aspect of the geospatial data. And the other aspect is descriptive characteristics. So on top of the location, I also want to show the type of the city, whether it is a capital city or a major city. In this case, I can symbolize the capital city using a star symbol with a circle outline and use red circles for the other city. Part of the information included in the cities layer is population information. So I can use that information to be displayed on the map. So this is the same three cities, but this time the points are represented by different point sizes and further emphasized by the varying shades of the red color to indicate the size of the population. With this, we can infer that of the three cities, the city of Manila has the highest population and the city of Cebu has the lowest. As we have seen from the previous example, varying the component of the symbol allows the user to show an attribute of the real-world object to be displayed on the map. Components of the symbol that can be varied visually show differences in the objects or features include shape, size, and color. And for color, we have two aspects of the color that we can use. These are color hue and value. In simple definition, color hue is what we commonly refer to as the names of the color, such as red, orange, or yellow. Color value is the shade of lightness for the same color hue. For instance, there's a light green and then there's a dark green. As much as possible, choose standard symbols used for mapping so that the users can easily decipher the meaning of the symbols. For instance, the color blue is typically associated with water bodies on the map. So if you would use purple to represent water bodies on the map, it may not be easily understood by the users. Now let's look at interactive apps, particularly the components that are included in it. When we are working with interactive GIS apps, it would have the following components: a base map, operational layers, an initial extent, and tools for navigating the map. A base map is a geographic frame of reference. It contains static data and it can be used in multiple applications. Satellite imagery or topographic map are common base maps used in many applications. And then displayed on top of the base map are the operational layers. These are the items of interest, the data sets that support the functionality of the application. The interactive maps that we have been talking about, wherein we have to choose the symbols. It is used for displaying the features included in the operational layers. Now, upon loading the application, it will zoom into an initial extent of the map as defined by the map author. This could be the whole world, a certain region or country, or your research area or project site. By defining an initial extent to where the operational layers are located, it is easier for the user to view and explore the geospatial data on the map. And then there are tools included in the app that would enable the user to navigate the map and view information. These tools can be used to zoom in and out, move the map, display a pop-up or table of descriptive information about the features on the map, among many others. All right, so it's time that we have a look at how we actually get to symbolize and visualize geospatial data in interactive maps and apps. So this is a desktop GIS application. It is an interactive map. The initial extent here shows the Philippines. The scale of the map is 1:12 million. And with any interactive map, the user can zoom in. And notice that as we zoom in, additional objects or features and even text are displayed on the map. And then we can zoom in further to see the UP Diliman campus. And at a certain scale, we can even see the building footprints and names of the different buildings within the campus. This is what I mentioned earlier about scale-dependent display. So far, what we've looked at is a base map. And specifically, this is the world's topographic map. On top of that base map, we can overlay our operational layer. In this case, it is a polygon layer representing the barangays in NCR, the National Capital Region. A layer in GIS is composed of the features which we see on the map and attributes, which are the descriptive information about the real-world objects. So let's choose a barangay from this table. This is Barangay Western Bikutan. It is in the city of Taguig. It has a population of over 87,000, and we can also see the area in square meters in the table. On the map, we see the barangay is selected. Currently, the map is only showing the location of the different barangays, but I can actually use these attributes in the table to symbolize the features. But before that, let me change the base map to a light gray canvas so that when we start to use colors on the features, it would have a nice contrast with the background. So the first one that we'll do is to use different colors for each of the city where the barangays are located. So once it shows the colors, we see the extent of the different cities as well as the boundaries of the barangays. If I wanted to make a reference map for the cities in NCR, this would be a good start. But let's move on with the showcase of symbolizing our features. This time, let's use the 2020 total population. The source of the data is, of course, the Philippine Statistics Authority. As we discussed, the interactive maps in a GIS can compile data from different sources. Now, looking at the result, well, this map gives the impression that a number of barangays in Caloocan, Quezon City, and Pasig, among other cities, could be congested simply due to the large population. But take note of the size of the barangays. Now notice that most of the barangays in Manila are displayed in yellow or light orange. And also note the small size of those barangays. So let's incorporate size of the barangays in the way that we symbolize our data. In this way, instead of showing the population, we are now showing the population density for each barangay. And when we symbolize the layers in this way, notice that the smaller barangays in Manila are now colored in the darker shades of orange and red, while most of the cities in the other parts of the metropolitan area are now colored either yellow or light orange. With the different ways that the data can be represented, it is the map author's responsibility to choose how to visualize the data in a way that reflects the real-world scenario in a manner that is accurate and true. Now, when I first started working with the GIS about 2 decades ago, what I just showed you was exactly the way that we created the thematic maps. Of course, the technology has made many advancements since then. And now I would like to give you a glimpse of some of the visual effects that we could add on the map and even include time or temporal data in our visualization. So from a desktop environment, let's move to a web app. This is a web map, and it provides an easy way to work and interact with geospatial data. The base map that I'm using here is the modern antique map. And the operational layer shows earthquakes data from the United States Geological Survey. This map shows the location and the magnitude of recent earthquakes. The size and color of the points representing the earthquakes depend on the measured magnitude. Now, looking at the map, there was something that I did not change here. Let me just change it back to the default. All right. So this is the default way that it's shown. And looking at the map, we see that the magnitude is mostly in the range of 4.5 to 6. So these are the yellow dots on the map. So it looks like there's a clustering of points over here. So that if I click on a point here, of course, I see its attributes, its descriptive information, and I also see that it is just but one of 15 points in that area. So I can explore this clustering of points by zooming in, maybe zooming in some more. And here I see that there are actually a number of points clustered there, earthquakes that occurred, which has 4.5 to 6 magnitude, but there are also earthquakes with higher magnitude of 6 to 7.5. So if I zoom back out to that initial extent that we talked about, to where I can see the Philippines and surrounding areas, and let me close that, I don't see those red points on the map. So I can actually now change it so that those that have a higher magnitude will be shown on top of the cluster. So there are earthquakes with high magnitude in the eastern part of Luzon and another one in the southern part of the Philippines. Well, now that these points are visible, it may be alarming to some users, especially kung dun ka sa area na yun na nakatira, right? So as you can see how data is represented on the map, it can actually invoke certain feelings or reactions for the viewers. All right, so instead of showing the magnitude of the earthquakes on the maps, let's just show the clusters. And I'll further enhance the display by adding some effects so that the points on the map blend rather well with that of the base map. So this map, it actually looks clean, organized, well, maybe some would say even nice. But I'm still not convinced that this is the best way to visualize the earthquakes data. There is a component of time in the data. So I can actually show the progression of the data through time. So let me shift to another web app for a clean interface in viewing the data where we can browse through the earthquakes data by month to see the earthquakes that occurred in January, there's one. And then in February, there's another one. And then in March, oh my, there's a lot more. And then in April. So this is an interactive map that I could actually share to non-GIS professionals so that they can explore geospatial data through time in an easy to understand manner. Right. So if you felt a little bit shortchanged that I didn't show how to enable time in the display of the previous web map, well, here's the setting for that. So under the properties, of the layer, there's that time, and you just simply enable the time. So the time slider, as we've seen previously, is a great way for animating data through time. It's animated and easily catches the viewer's attention. But it can also be a powerful tool to see what has changed through time. So this web map that we are seeing now shows an operational layer of the land use, land cover map. And this layer is derived from the Sentinel-2 imagery, and it has a 10-meter resolution. Now, when we overlay an operational layer on top of the base map, what it actually does is that it covers the base map. So let me just turn that off so that we can see the base map. And the base map is a topographic map that shows the terrain of the surface. So let's now turn back the operational layer and let's blend that operational layer with that of the background so that what we see on the map, we still see the land use color, land cover based on the color being used on the map. But at the same time, we get to see the relief of or the terrain of the surface. And what we're going to do is again visualize the map through time using the time slider. And this will bring us to a year per year animation of the data. So in 2017, 2018, 19, 2020, and 2021. But then seeing the data in this case year per year, it doesn't really give us a sense of how much has changed. So let's just compare the 5-year difference. So let's look at 2017 and compare it with 2021. So if you've missed that, let's look at it once more. The 2017 data and then the 2021 data. And you can really see how much built up area has sprung up in San Antonio, Lipa City, and San Jose. As I said, this is a powerful tool to see what has changed through time. So even with the terrain data that's visible on the map, this is still a two-dimensional map. With another type of interactive data, if I can browse through it. Okay, here we go. Aha. All right. So this is another type of interactive web map, the web scene, and we can view our data in 3 dimensions. The 3D model can be in non-textured format. On this scene, the Eiffel Tower and the trees are not just flat points on the map, but the objects have height and actually come close to resembling the objects on the real world. And because I am afraid that I will lose the next 3D scene, let me just go back to my PowerPoint presentation. And then show 3D data. Okay. 3D maps are great, but with the way that my internet is lagging, maybe not so much. Let me see. Let me go back to this PowerPoint because I made, here we go. So this is actually the 3D scene that I wanted to show. And here, it's the same 3D model, but texture has already been applied so that the scene resembles the reality a little better. All right, and then I think I have access to the last one. Now, 3D modeling is not just for the outside world. 3D scenes for indoors can also be created. This is a virtual exhibition by the Smithsonian American Art Museum that showcases the exhibit for Alexander von Humboldt and the United States. Here we have a 3D scene, and on the left panel, we are provided with information about the exhibit, and we can browse through the story and enter the exhibition to view a 3D model of a mastodon. All right. Our world is in 3D. So the way that we represent them in interactive maps and apps can also be in 3D. Now, this is the last app for the showcase, notice that aside from the web scene, there are also text. And if I scroll down a little bit here, I also get some photos included that helps tell remarkable stories. So if you have produced several maps from your research work and want to incorporate a write-up for your findings, this story map is the best type of interactive app that you can use for sharing and presenting your results. And also note that the browsing experience is similar to browsing any other website. It's easy to use, and you definitely do not need a GIS experience to use it. Oh, right. So based on what was shown in the feature symbology demo and interactive map showcase, there has been recent advancements in geospatial technologies, and we can harness these new features and functions to author interactive maps that are appealing and informative. A map is such an extraordinary tool that enables us, the users, to explore the world and get a better understanding of it. By integrating these maps in apps that we can use on the web or in our mobile devices, geospatial data may be used not just by the GIS professionals, but it can be accessible by anyone in a way that is simple to use and yet engaging. The fusion of maps and apps can provide us with insights, even encourage us to act, and well, depending on the map and app, there dare I say, it can help us make decisions that could make this a better world. And with that, I would like to greet everyone a happy Earth Day. If you want to know more about visualizing and beyond to analyzing geospatial data, feel free to reach out to me or my colleagues at Geodata Systems. The contact details are on the slide. And if you have questions for me now, we have an open forum next. So I'll turn it over back to TJ.
All right. Thank you very much, Ma'am Kathy. I can sense that our participants are looking forward to use these applications in the near future or either in their work. Also, if you have any questions or comments, I would like to invite our participants to type in those questions or your reactions in our Zoom chat box for our open forum. All right. So thank you very much again, Mom Kathy, for that very interactive and also lively presentation on interactive maps and apps. Sure that everybody can use that in their line of work or maybe in their in other
TJ.
endeavors. All
TJ,
right.
while we're
Yes.
waiting for the first question to be asked by our participants, since dati akong moderator, sanay ako maging moderator. So let me ask you this question. Anong naging favorite part mo doon sa interactive maps and apps, TJ? Was
Well,
it the 3D maps?
actually, I'm very amazed with the 3D maps that you have shown earlier, and I was also paying attention to the way you have manipulated some tools that we need to look into so that we can properly show information and I have also catched up yung sinabi niyo po kanina about how crucial the map author's role is. So I would like to ask you this question, Ma'am Kathy, if I'm not sure, I hope you don't mind this. How crucial is the map author's responsibility? You mentioned this earlier that from the point of view of the map author, um, they have a crucial role in showing whatever information that they have they wanted to show. So how crucial is the role of the map author in terms of making those maps and showing the kind of information that they wanted to show to the public?
Yeah. The map author, actually, when preparing the map, ang tawag ko dyan, God mode yan. You have complete control of what information gets put into the map. So the role really of the map author is very, very crucial. The map author has the power to choose what to show, even what to delete from the data. And as we've seen from the presentation, using the different tools in a GIS software, for instance, you can emphasize or de-emphasize something. So you can actually create a map that tells something, makes people react in maybe a violent way. Um, but in reality, that is not the reflection of what is going on in the real world. So really, I made it part of my presentation to call on the geographers, the map makers, to feel that responsibility, to have that accountability, that every time I prepare a map, someone else is going to be looking at it. Someone else might actually base their decisions on that map. For instance, when we open Waze, for instance, in the morning before going to school or going to work, we base our decision on what the app is telling us. So, in the same way, if I'm authoring a map that can be used by others, I can also have that call to action for that user to do something. And it may be as simple as going from point A to point B, but you also have to remember that maps are used in policy making. Maps are used in allocating resources. So if I made an erroneous map or intentionally made an error in the map so that people decide to do something in my favor or in another group's favor, then it's not really a clear um, or accurate representation of the data, but rather a manipulation of the data. And sadly, the map author has the power to do that. So be responsible if you're making a map. Depict the real world as it actually is.
All right. So you mentioned, Ma'am Cathy, regarding the map's role in making decisions and policy making. So how, let's say, for example, if we have members of the audience who are, for example, decision makers, how can they use maps in making those decisions? Especially, let's say, for example, right now we are celebrating Earth Day or etc. So how we can use maps really, for example, to make crucial decisions in it, for example, in environment or allocating scarce resources that we have.
Right. So in the last 2 years, we have been in a pandemic, right? So if I actually come up with a map that shows where the vulnerable population is, and that will be used for allocating resources for that segment of the population. So if I want the resources to be sent to a certain barangay because I have my family members there, I can just make it a color red, meaning that, oh, there's a big segment of that population that needs help. So send help, please. So I work with utility companies, and I know that some of the companies that I work for, that I work with actually, they use the GIS. For instance, if there's a storm and they look at the path of the storm, the forecast where the storm is going, and study the map where to place their repairman, for instance, for the lineman, for instance, so that after the storm, their resources are ready to put back power in case lines fall down during the storm. So that's also a use of maps in the way that companies run their business, even, and the way that we as consumers of water or utilities are actually benefiting when these companies use the maps in making decisions that are informative because it comes from a source that's authoritative.
Thank you very much for that, Ma'am Kathy. And there are questions coming in our Zoom chat box. This is from Pau. What web app was presented earlier? Is that bundled with ArcGIS Pro? I plan on using it in my work. Can the maps be edited or updated collaboratively online?
Right. So the first one that I showed in the showcase is the desktop one, and that is ArcGIS Pro. But much of what I did is through ArcGIS Online. Um, and I'm not sure, Pao, if you're a student or if you're a consultant, but ArcGIS Pro is an annual subscription. So it means that the cost of the software is lower. And the thing is with ArcGIS Online, you can create your own data, update it. The layers that I've used for the demo, they are curated by the makers of the software of ArcGIS, and it is read only. So those layers cannot be updated. But if you create your own data, you can definitely edit and update it as well.
Thank you very much, from Kathy. There's another question from Rowena. Good afternoon. It was not presented, but I am curious if there is or are features or properties in this interactive map that can be used to stimulate Earth or plate movements.
Aha. I think so. There would be. When I was looking at the available layers, so I actually just took a small part of a larger data set, the earthquakes part. But what the creator of the software did is actually, well, collate data from different sources, and they actually have a layer that includes the plates. I'm not sure about movements, if there is, but I think if you have the plates on a map and you have a data source that tells you how much movement and the direction of the movement for those plates, you can actually input that information on the GIS and show that plate movement through time using animations as well. So it's possible. Again, I think someone in the GIS community said that the GIS is only limited by your imagination. So I can definitely imagine using the GIS for simulating the plate movements.
Right. Thank you very much, from Kathy. This question is from John Cristababa. Good afternoon. I'm CJ from Philippine Normal University. Do the following web maps accessible to any users? Do you have more suggested interactive application maps suitable for a classroom setting? For example, if teachers would like to use these applications in their class, say in teaching history or geography and other social studies courses in basic education, even in college. Yeah.
Yeah, I actually taught digital cartography before in UP for the Department of Geography, and I actually used ArcGIS products as well. And I found many materials that I've been able to incorporate into digital cartography. There are a lot more data that's available out there. Um, there are also some communities that provide open data. You just have to really be diligent and look for these sites, these communities. If you're subscribing to ArcGIS Online, there are a lot of authoritative, curated data sources similar to what I've shown in the demo. And I see Sir Joe has his hand raised.
Great.
DJ, you want to
Yeah.
call him?
Yes. Sir Joseph has a question to ask. Sir Joseph, please.
Yeah, thank you. Actually, I have this is not a question. It's actually a private message sent to me by a member of the audience. I just want to read this. Here's the comment. The presentation was very insightful. However, I did notice that the examples were all very visual. I am now also curious about interactive maps that cater to those with impairments when it
Uh-huh.
comes to their vision, more in terms of accessibility, and if there are already existing options for them. Thank you.
Oh, yes, definitely. In the template where you can choose the colors, there's actually a subcategory for the visually impaired. So you can actually choose colors that would cater for that segment of the population that needs help seeing colors. So yeah, there is. I didn't show it, and if you give me time, maybe ask another question. I can look for it. I saw it when I was browsing, but yeah, okay.
Right. Thank you very much, from Kathy. There's another question from Sock Mariano. He's from Metro Pacific Tollways. We have created some apps from ArcGIS experience. We'd like to know how it can be hosted in our mobile app in the MPT Drive Hub. Our app is hosted and built in with OutSystems, which utilizes JavaScript for its source code.
ArcGIS experience. Is this experience builder? Uh,
Uh,
Sir
uh,
Socrates, if you, because I'm not sure about the question
sure.
about experience, if
I
it's
think
experience builder.
I think, Sir Sok, you can raise your hand, but you can maybe clarify your question to Ma'am Kathy, or you can unmute, sir, if
Mm-hmm.
you're here.
Yeah.
Web Experience Builder, he said.
Okay. So if it's web experience builder, it's actually already hosted on the web if you're using ArcGIS Online. The thing is, it's web based. So any web based application relies on an internet connection. Uh, so even on a mobile app experience, the user uses a mobile device, sure, but they still need to open a web browser. So either it's Safari or Firefox, Edge, or what your browser of choice. Um, and they would need to have internet connection. You can actually, there is no native app for the experience builder. Um, I'm thinking, well, you can always create your own application that runs on a native um, mobile device, but you would have to host it. The RGS platform does not come with hosting um, customized applications native for the mobile device.
All right. Thank you very much again, Ma'am Kathy. There's another question from Owen. Anything that you can suggest in support of the PGS in its geospatial endeavors? What?
Aha. Mm, I'm thinking because a lot of the activities of the PGS has to do with counter mapping, 3D mapping. Maybe this is something that we can collaborate in using the ArcGIS platform because I know there are a lot of activities like that.
All right. There's another question from Cristiano Salvacion. What legal implications must be considered in creating a web or app-based interactive map, besides acquisition of rights to public or private data? For example, if we are going to map controversial events.
Controversial events. I'm not sure what that means exactly. If you're sourcing your data from another organization, make sure that you read the terms of use. And actually, when I was preparing the demo for this presentation, I was very particular about that. Being able to cite the sources, making sure that in the terms of use, I can use it, even for just a simple presentation. Um, but if you are building your own data and you're not showing personal information, or if you collected personal information, just make sure that you anonymize it so that there's no personal information that's coming out, because you don't want to violate any of the personal data privacy act, right? The data privacy act. So that's something that you have to be considerate about. Um, Usually, if you're creating an app, or if you're creating a description of your data and you're publishing it, make sure to add a disclaimer. Especially, for instance, if you're using boundaries, administrative boundaries that have disputes, like some barangays would have disputes with neighboring barangays, right? And you really just have to choose one source, um, to draw your barangay so that you can show it on the map. So if you're going to use a barangay boundary and you don't want to be called out, because someone used it for some legal transaction to claim something, um, just make sure that you add that disclaimer that it is not an authoritative source. And it can only be used for visualization, but not for any legal transactions.
Um, okay, so I think I have another question coming from me, Ma'am Kathy, because
Mhm.
there are other maybe members of the audience or who wanted to enter into the GIS profession,
Uh-huh.
who wanted to do GIS for the first time, and they seem to be intimidated in the way things are being done or how things are being manipulated in terms of the technology or the applications. What advice would you like to give people who wanted to enter or who wanted to do GIS for the first time, and just to ease the feeling of not being intimidated, or they would enjoy doing what you're doing in your work?
Right. So the first one, really, the first advice would be, don't be afraid. Don't be daunted by all this technology. It's still a piece of technology. I mean, just imagine the complex technology behind the cell phone, and you're not afraid to use that, right? You use it every day. So it's the same thing. GIS is also a piece of technology, and just like any technology, it can be learned. Sometimes the learning curve, well, depending on your learning capabilities, but it can be in as short as a week, or it could be a semester, or a course of 2 years. So it really depends. What helped me understand ArcGIS specifically, the products, is attending a number of different courses. And sure, it may cost money, but that is your investment. If it's something that you really want to learn. I mean, when we go to school, it is an investment, right? Because we want to earn a certificate, a diploma, a degree. Same thing with the GIS. So I think when you study GIS, it is not for hobby, it is not for sport. It is really for professional development. And it is very rewarding because there are a lot of opportunities now for GIS professionals. So look for trainings. Um, Geodata Systems offers training. I used to teach courses in Geodata Systems as well. So I taught a lot of those basic to advanced courses. I actually learned from those courses as well. And I think my work as a teacher helped me to learn more about this particular technology. And then, of course, nowadays, online, there are a number of different courses. If you can check Coursera, um, they also have GIS courses there. And then, of course, if you're subscribed to ArcGIS Online, you have access to the ArcGIS learning modules within the platform. So there are many resources, both online and instructor-led courses for you to start to dip in your toes and get into this GIS technology.
All right. Thank you very much, Kathy. Are there any questions or comments? Okay. So there, Karen Dandicho has shared some free online GIS courses. You can visit the website that she has typed in our Zoom chat box. So you
Yeah.
can check this out. It's www.sg.com/training/mooc. Okay, so there's another question from Jonas. Good afternoon, Ma'am Kathy. Can you share some of the challenges in doing GIS?
Aha. So I think I can talk more about implementing GIS in an organization because I think personally or professionally, we've discussed that with TJ's question. For an organization, implementing the GIS, the challenges there would be sometimes there really just are people who are averse to any technology, including the GIS. They're so set in their ways. So you really want them to ease in to this new technology, get them aware about the changes, make them appreciate how this software, this application can actually help them in the work that they're doing. And that it's simple. We can actually make it simple for you. We can make it even fun for you. Um, and then, of course, there are challenges also. Since we are in the Philippines, the availability of the data. I mean, I go online and I see and I search for Philippine data and I get like 7 search results. But when I do search for other countries, there's like hundreds of search results. So the availability of data, and not just availability of data, but availability of accurate and correct data, curated data is something also of a challenge, and whether also if it's complete. So the other thing is, of course, GIS is a software and it is always paired with its hard component, the hardware. Sometimes the person using or the organization using doesn't have the hardware, doesn't have the infrastructure to implement the GIS. Even as simple as a fast, reliable internet sometimes is an issue, especially if you're using ArcGIS Online, when you need an internet connection, a fast internet connection to be able to access these applications. Notice how I did not interact with my 3D scenes. It's because gumagapang na siya. If I try to zoom in to the Eiffel Tower or to the France 3D web scene, it will just lag. It's not a good experience. So even having to display it was a challenge already. So sometimes the infrastructure can also be a challenge. Yeah.
We hope that we're able to address all the questions. Are there any questions from our participants before we conclude our session this afternoon? Going once, going twice. On that note, Ma'am Kathy, thank you very much for answering the questions, some comments or reactions coming from our participants. We hope that our participants were able to learn and gain a lot of insight about your work, and later on maybe be encouraged to do GIS work in their future endeavors, or maybe in their line of work they could also apply what you are doing. So thank you very much again, Ma'am Kathy, for joining us.
I'm so happy to
So
be here.
now, to show our appreciation, the Philippine Geographical Society would like to present this certificate to our speaker. This certificate of appreciation is given to Kathy Angela Ilustre for the valuable insights and expertise shared as virtual resource speaker for the talk Visualizing Geospatial Data in Interactive Maps and Apps as part of Philippine Geographical Society Lecture Series 2022 held on April 22, 2022, signed by Professor Joseph Palis, Chair of the UP Department of Geography, and Professor Emmanuel E. Garcia, President of the Philippine Geographical Society. So again, thank you very much, Ma'am Kathy, for being with us this afternoon. We have learned a lot from your talk, and we look forward to having you again in the future. Thank you again, Ma'am Kathy.
Thank you very much. I was very happy to be invited to speak, and I'm very happy to share what I know about GIS. And I hope you've learned something new from it.
Yes, definitely, definitely. Personally, I was able to get a lot from your presentation, Ma'am Kathy. And with that, we are now gearing towards the end of our program. I would like to call Professor Joseph Palis, the chair of the UP Department of Geography, to give his closing remarks.
Thank you, TJ, and thank you very much, Kathy, for the wonderful presentation that generated so much responses from the audience. And I'm sure there are a lot of other questions. And maybe it would be good if you could also put your email. I know you put it at the back, at the very end of your slide, but it might be good to just put it in the Zoom chat. But what I really wanted to ask you was about story maps. I'm kidding. So that's kind of a private joke. Earlier, when Kathy and I were speaking about her presentation, and she asked me about the number of minutes, how long does it take for her to get to to talk about to cover as much ground, right? And then she said, "Oh, I may have to take out the story maps part, which you love so much." So I said, "Oh, I'm gonna get back at her and say, what about the story maps?" I mean, basically, what it means is that there's a lot of things that can still be covered, but in the interest of this lecture series, it's a teaser, right? It's supposed to make you want to know more about it, and you can contact Miss Kathy Ilustre at Geodata for more details. I would just like to talk about two things, and one of them was a build-up on what one of the participants asked earlier, maybe more as a kind of rhetorical question, but probably this was posed as a question more about for people with impairment, you know. And of course, Kathy has mentioned there is such a thing too, but at the moment she did not prepare for it because of other information that she prioritized in her talk. But maybe this is one thing we also need to consider, because of the not all of us are gifted with a gift of sight that is as excellent as the others. But what about those who wanted to also work on GIS, but with very specific kinds of impairments? The other thing that I also wanted to respond to, which was also touched on by Kathy, was how the GIS is just a technology. It can make things visible, geospatial data, but I think there's also a caveat about responsibility, about the sort of thing that we make available for people, right? So when in your desire probably to capture all the data, you may want to ask yourself a question about whether vulnerable groups or collectives or communities may be impacted by making those data available, you know. GIS is from a geographer's perspective, from someone who comes from an analog world, who studied digital cartography in its analog version. This is especially a welcome talk, not only because of the technology that has aided many cartographers during my time, but also a way of showing that it has become democratized in recent years. And I believe, sorry, Kathy already posted the link for the one for designed for the colorblind users. So there you have it. But there's also something that Karen Lendicho posted from ESRI website, right? Courses, you know, just to make sure that we are conversant with the new language of mapping. So once again, our heartfelt thanks to Kathy for touching on those issues and making us pay attention to them in novel and fresh new eyes. Thank you very much. At this point, I'd just like to invite people to the two more lecture series that we have planned for you. The first one that's coming up is on May 6th. It's actually an extension of the course that's being taught by Professors De Guzman and Ocampo called Geographies of Hallyu, and invited a scholar, Ha Huang, originally based in Vietnam, but based right now in Western Sydney University, who's going to talk about K-pop, redefined masculinities and fandom reception. Should be an interesting one. 5:30 p.m. next Friday. And then Luigi Toda from Arab is going to give a talk on May 21. That's a Saturday, rather early time though, but it's a Saturday anyway, 10 a.m. If you could come to that, Luigi is trained at Australian National University and also our alumnus from the UP Department of Geography. He's going to talk about measuring vulnerability and resilience. And for the month, although we haven't posted them yet, but stick around also for the months of June and July and August, even if classes are not yet being conducted, we will still continue with our lecture series. So thank you.
Thank you very much, Professor Palis. Now, before we end, the Philippine Geographical Society has an open call for membership. You can visit www.phgeographicalsociety.org for more details. And also, if you want to revisit the past sessions of the PGS Lecture Series, these can be found in the UP Department of Geography YouTube channel.